Hey everybody, we are looking at this problem coin change. You are given an integer array coins representing the coins of different denomination and an integer amount. Something like this. Coins is 1, 2 and 5 and amount is 11. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made, we are supposed to return -1. We can take any coin infinite number of times. There is no limitation. So let's take a look at example 1. Coins is 1 to 5, amount is 11. What would be the minimum number of coins? 5, 5 and 1. 1 can also be taken 11 times, but that would be 11 coins in total and we don't want that. There's a possibility we can have 2 5 times and then 1, so we have total of 6 coins, and that is also not acceptable because we are getting a output of 3, which means total number of 3 coins minimum. Over here coins is equals to 2 and amount is 3. We cannot create the amount 3 over here. In example 3, coins equals to 1 and amount equals to 0. To create an amount 0, we don't need any coin at all, so the output would be 0. In this problem, since we are making decisions of which coins to take and how many times should we take it, we can visualize this problem better with a decision tree. So let's say that we have coins equals to 1 to 5 and amount we want to create is an amount of 3. So let's say I want to create a 3 amount here. I have 3 choices. I can take 1, or I can take 2, or I can take 5. If I take 1, the total number of sum left I have to create is 2. If I take 2, the total sum I need to create is 1. If I take 5, I cannot. This is not possible. I need to create an amount of 5, amount of 3, and I have a 5 coin. This cannot be taken. So 5 cannot be taken in this case. After this, I have multiple choices. We know 5 cannot be taken, so let's not just take it. This 5 cannot be taken. If I take 1, I am left with creating a total sum of 1. If I take 2, then I have a total sum of 0. So basically I reached. So what is the total number of coins required? 1 and 1. Over here, this 1 and 2 is the coins required, but the total number is actually 2. In this case, I can have 1, I cannot take 2 and cannot take 5. If I take 1, I get a total amount as 0 left. So again, 2, 1, total number of coins 2. We are just left with this one, and this would not be a solution. We can see that if I take 1, we have a total sum of 0. So 1, 1, 1, that would be 3 coins. So we can say that from these 3 choices we have, the minimum is 2. So what's going on here? You can make this observation that what if at every stage, let's say this one, I am basically checking which one of these trees is going to give me the minimum. And over here, you can see that this tree is going to give the minimum. To create an amount of 0, you need 0. And then you chose 2, which means you chose one more coin, and that gave you a total of 1 coin to create a sum of 2. From this path, you had to choose 2 coins in total, one from here, one from here. So you chose 1 plus 1, and you can add this 2. So 0 plus 1 plus 1. And you created a total number of coins as 2. Very similarly with this, and very similarly with this. So we successfully broke down this problem into its sub problems. If you know the total number of coins for this, you can find out total number of coins for this. Also, we are solving the same problem again and again. You can see here, this subtree is the same as this subtree. So in this problem, we can use concepts of dynamic programming and we can store these subproblems and optimize our solution. To store the subproblems, we are going to go in a bottom-up approach. We would have a storage, let's call it store, and this store would stretch from an amount of 0. This would store the minimum number of coins required to create an amount. So from amount 0 to an amount of amount. So that is a total length of amount plus 1. This is what we would use, and it can be a simple array or it can be a map. It doesn't matter. I'm going to use an array. So this would be the basic algorithm to solve this problem. Let's take a look at the code implementation, and that would help you understand it even better. So here in the code editor, we have this function coin change. It accepts coins array and the total amount, and we are supposed to return an integer. The first thing, I would like to create a storage. So let's call it store. It's a list and it has a total size of amount plus 1 because we want to go from amount 0 to amount of amount. Also, because I want to store the minimum in this, I would assign it with a float of maximum. So I can assign it a maximum value, which is infinity. Then we need to initialize this store. There is a value we know. So store of 0, we know that would be 0. To create an amount of 0, we need 0 number of coins. Next, I would like to go bottom up, which means I would like to find out the solution for amount 1 and then amount 2 and then amount 3 and so on until I reach the amount. So I can go something like for a in range from amount 1 because 0 is already assigned to amount, which is amount plus 1, so that I go till amount. This way we would be able to create all the we will be able to find all the sub problems, and then we find the bigger problem. For every amount, I have multiple choices. I can take any of the coins. So for C in coins, now can I take all the coins? Not really. I can only take a coin if its value is smaller than the amount I want to create. If amount minus or amount less than, or we can just amount minus coin greater than equal to 0. We can write something like this. If amount is smaller than the coin, and only in that case, I want to take this coin. So what are we doing here? What happens when I opt for a coin when this is valid? So let's draw it out. Let's say I wanted to create a sum of 3. I have 1 to 5 in choices. So 1 is here, 2 is here, and 5 is here. I get a sum of 2, I get a sum of 1, and I cannot take this coin. What I'm doing here, I'm basically saying from 3, looking from 3, I'm saying give me the minimum number of coins required to make 2. Give me the minimum number of coins required to make 1. And then I would add 1 more coin to it to create a sum of 3, either by taking 1 or by taking 2. So what we are doing here, let me write that in code. To create an amount of A, I am going to choose the minimum of either what is already present or 1 plus store of A minus C, which means either this or this in multiple loops of this for loop. So this would give me the minimum number of coin to create 3. Now that we are done with this would loop until amount, and store of amount would be assigned something. Now there is a possibility that we just cannot create amount at all, which is example number 2. In that case, we are supposed to return -1. Our code will not give us -1 at this point. So we need to check that. So if let us return -1 if store at amount is equals to infinity that we set, which means this value got never assigned. We were never able to find anything at all. Otherwise, let's just return the store of amount that would be the minimum number of coins. Let's try to run this code. Let's submit it. It's passing, so we have a solution. If this video was helpful to you, please consider subscribing for more such content.